simultaneous equations. This is where we use these when we're asked to find the point of intersection, or if we're trying to find where two lines meet. There are three methods we can use to solve these, and you can use any of them. One is usually more suitable than the other. We're actually going to just focus on two different methods. So we're going to look at elimination and substitution. So solving simultaneous equations involves finding one value of x and one value for y that have to satisfy two different equations. So elimination. So this involves eliminating, which means getting rid of one of the variables, so either the x or the y, to allow you to solve for one letter. You then substitute that letter into the other, into either of the other equations in order to find the other letter. Eliminating one of the letters is done by adding the two equations. Okay, but in order for the term to be eliminated, we need to have one term that will disappear when we add them. Now, how does that happen? Well, if things are going to disappear, we need to have the coefficient, so the number in front of the letter has to be the same, but it has to have different signs. So, for example, if we have here negative 7x plus 7x, we know that that's going to become 0. If we have 2 plus negative 2, that's going to become 0. 5 plus negative 5, 0. Negative 4 plus 4, 0. So it doesn't matter what the letter is, we know that because the number in front of those letters are the same value but opposite signs, it will eliminate them. So that's our aim. Now, if the criteria is not met in the original question, then we need to multiply one or both of the equations by some value to make the coefficients the same. Easiest thing for me to do is to go through several examples with you. So, looking at this first example, solve 3x plus y equals 5 and 2x minus y equals 10. Best thing to do here is to line the two equations one above the other. So 3x plus y equals 5, 2x minus y equals 10. Now you notice I've got my x's in the same column and my y's in the same column. Let's just get rid of those marks. Okay, so 3x plus y equals 5, 2x minus y equals 10. That's from just copying our question. We now look at the coefficients, so let's focus on the x's. We can see that this one has a 3 and this one has a 2. They're obviously not the same number, so let's have a look at the y's. I can see in front of the y, there is no number, which means there's a secret 1, and this y also has a 1. So we have satisfied that first criterion that we have the same number in front of the both y's. We then need to check, is the sign different or the same? So we can see that this one has a plus 1, this one has a minus 1. So we've satisfied that criteria as well. Now what that means is that when we add these two equations together, this plus y and minus y is going to disappear because they have the same value. So when we add them in columns. So we have 3x plus 2x gives us 5x. We know that this has disappeared, and this gives us 15. We then have x equals 15 divided by 5 because we've divided both sides by 5. And so x is equal to 3. Now our question isn't finished because we've only found the value of x. What we now do is substitute this value of 3 into either of the original two equations. Now one is normally more suitable than the other. In this case I'm going to choose this equation to substitute it in, simply because the value of y is positive in this one. So let's just write the equation out. 3x plus y equals 5. I know that x has a value of 3, so this is going to be 3 times 3 plus y equals 5. 9 plus y equals 5. And then we're going to subtract 9 from both sides, so that's y equals 5. Take away 9, so y is negative 4. So here we have our final solution. X is 3, y is negative 4. Second example. Again, we're going to line up our two equations. So 2x plus 3y equals negative 6. Now notice they've written this equation in a different order. They've written the y, then the x. But I'm going to write it in the same order as I have in the one above. Now notice the negative sign belongs to the 2x, so my negative sign stays with the 2x. The y doesn't have a sign, so that's a secret plus. We know we're going to add these two equations, so we need to double check our coefficients. So I can see my x has a 2 and a 2, perfect. It has a positive 2 in the first one and a negative 2 in the second. So when I draw my box around these two things, I see because this is a 2 and this is a negative 2, they will disappear. We then add our two equations. So 3y plus y gives 4y. Negative 6 plus 14 gives us 8. And then we're going to divide both sides by 4, which gives y equals 8 divided by 4, which gives y is 2. Again, we must complete our question by finding the value of x. Again, look at both of your two original equations. It doesn't matter which one you put them in, but in this case I'm going to choose this one because my x has a positive sign in front of it. So notice we found y this time, so it's going to be, let's just write the equation first. So it's 2x plus 3y equals negative 6. So we know that y is 2. So 2x plus 3 lots of 2 equals negative 6. 2x plus 6 equals negative 6. So we need to subtract 6 from both sides. So we get 2x equals negative 6, take away 6. So 2x equals negative 12. Now we're going to divide both sides by 2. X equals negative 12 divided by 2, which is negative 6. So there's our two solutions. X equals negative 6 and y equals 2. Next example. 5x minus 3y equals 13. 2x plus y equals 3. Now we know we're going to add our two equations, but when we add them we want either our x's or our y's to disappear. Remember, for that to happen, the number in front has to be the same as for each equation, but different signs. So here I have 5x and a 2x. Obviously that's not the same number, so let's check the y's. I have 3y and 1y. Again, not the same number. So this is the first time we are actually going to have to alter one of our equations. The easiest way to do this is to change the y value, or what we're going to do is we're going to make the number in front of the y's the same. Now the reason being is that because we only have one y in this second equation, it's a lot easier if you're going to choose that one. So I can see in this equation I have 3y, and this one I only have 1y. So what am I going to do? I have to multiply the whole equation by 3, and I'm multiplying by 3 to make sure that I have the same number as the one above. So instead of 2x plus 1y equals 3, I'm going to have 6x plus 3y equals 9. And notice everything in the equation has been multiplied by 3. If I were to then write the original equation, the first equation underneath now, notice I haven't changed anything. I can then double check that my signs are as I want them. So I have positive 3y and negative 3y, so that's great when I have my box around them. When I add them, because this is plus 3 and this is minus 3, they will disappear. So, oops, this is where I can do my adding. So 11x equals 22. Divide both sides by 11. So x equals 22. to the 11, which is 2. We need to find our value for y. I'm going to choose this version because y is positive. So that's 2x plus y equals 3. But I know that x has a value of 2. So it's going to be 2 lots of 2 plus y equals 3. And then I'm going to subtract 4 from both sides. So y is negative 1.